Hello students. In today's class we are going to get a very interesting concept, that is the concept of rotational symmetry. Let's first see what is called rotational symmetry, that is when a figure is said to be rotationally symmetric. Let us consider this figure. Suppose we are given this particular figure. Here we can find two mutually perpendicular lines AC and BD are there, right? Now, taking this particular point of intersection as the center, let's rotate the figure. Suppose I am rotating it by an angle of 90 degree. Here you can see this. So what will happen after this rotation? Look at the second figure. Here we'll get that this particular point will come over here at the extreme right position, and gradually all the other points will be shifted. This D will come down, this C will come over at the extreme left position, and B will come at the top, right? And make sure students, if you see the configuration of this second position, you will find the configuration is exactly the same as the original one. Now let's rotate, taking this intersection point as the center, again by an angle of 90 degree. Here it is again rotated by 90 degree, right? Then what will happen? You will find that this particular point A will come down. Here you can see this in this third figure. And gradually the other points, that is D, C, B, are getting arranged, right? Because the figure has been rotated again, taking this intersection point as the center. And you will also find that the configuration in this third figure is also the same as the original one, right? Now again, this third figure is rotated by the same angle, that is the angle of 90 degree. So obviously A will come over here, and gradually the other vertices, other points will be arranged, right? And again we are getting the same configuration. Though the points are shifting their place, but the configuration is remaining the same. Now this particular figure is again rotated, taking the same intersection point as the center by an angle of 90 degree, and then we will find that the configuration is not only same, but also A is again at the top, C is at the bottom, B is at the extreme left position, and D is at the extreme right position. That is, again we are getting the exactly original figure, and obviously configuration is the same. So look students, here for each rotation by the angle of 90 degree, we are getting back the original structure, original configuration. So we will make the conclusion that this original figure, given figure, is rotationally symmetric. And here, as by the rotation of 90 degree, we are getting back the original configuration in all these cases. So this 90 degree angle will be treated as the angle of rotation of this particular figure. And what is the order of rotation? Look students, after first rotation we are getting the same configuration, after second rotation we are also getting the same configuration, after this third rotation we are getting the same configuration, and then after fourth rotation we are getting the original structure again, that is the same configuration. So after 4 rotations, for each of these 4 rotations we are getting the original configuration. So this way we are making 4 rotations, right, in order to get back the exact original figure. 1, 2, 3 and 4. So order of rotational symmetry is here for this particular figure is 4. So this is the brief concept of rotationally symmetric object. Now let's check the rotational symmetricity of a few geometrical figure. First of all, I have taken an equilateral triangle. Though we should mark all 3 vertices, but here for your convenience I have just marked one of these 3 vertices as capital A. Now I have taken a transparent paper, and there the same triangle with the vertex A has been drawn. Now let's judge the rotational symmetricity of this equilateral triangle, whether it is there. If it is there, then what about the center of rotation? What about the angle of rotation? What about the order of rotation? Let's judge. Okay. So I am placing this particular transparent paper on this figure. Here you can see it is completely matched. Okay. Now this is vertex A. Now these are the three medians of it and this is the point of intersection. So let's take this intersection point as the center of rotation. Let's see that after taking this intersection point as the center of rotation and after the rotation, whether the same configuration is obtained or not. Let's rotate it. Because for the rotation you need a center. So I am taking this intersection of three medians as a center. So now I am rotating. You can see this. Hence it is rotated. And you can find that the same configuration is obtained after this rotation. Though the vertex A has been shifted over here, but the same configuration, it's again fully matched, is obtained by this rotation. Okay. Now again I am rotating this figure. Again I am rotating this figure. Let's see whether the same configuration is obtained or not. Yes, again we are getting the same configuration. Though the vertex has been shifted over here, but the configuration is the same. Let's see another rotation. Let's do another rotation. And here we get that after this rotation, again, we are getting the same configuration and also the vertex A has come to its original position. So what is our conclusion? Is this triangular figure, equilateral triangular figure, rotationally symmetric? Yes, it is rotationally symmetric because for several rotations, we are getting the same configurations back. And in all the cases, the angle of rotation what we made in each of these cases is less than 360 degree. So here we can see that in case of an equilateral triangle, center of rotation is the point of intersection of three medians of it. Now, how many rotations did we make, students? That is, how many times after rotation we got the original configuration back? That is, what is the order of rotation? Can you say this? Yes, that was 3 because we had rotated the figure for 3 times. That is, for 3 times we got back the original configuration. This one, first of all, we rotated along this direction, then along this direction, then along this direction. And then for each of these rotations, we got the same configuration back. So order of rotation is 3 and then angle of rotation. There is a rule of finding the angle of rotation of any symmetrical, rotationally symmetrical figure, that is, just divide 360 degree by the order of rotation. And hence, for this triangle, we get it is 120 degree. So here the conclusion is equilateral triangular figures are rotationally symmetric. Now let's judge the rotational symmetricity of the figure squared. Okay. Here also out of the 4 vertices I have selected one. I have marked one as capital A and also the same configuration is taken in this transparent paper. Okay. So here I am placing this on this original figure. You can see it is perfectly matched, right? Okay. Now I am taking this point of intersection, that is point of intersection of the 2 diagonals of it as a center. And I am rotating this. Let's check what happens. I am rotating this, right? And this is the first time, that is through rotation, I am getting the original figure back. Okay, and the position of A has been shifted from here to here. Again, I have started the rotation. Remember, first rotation is completed. We have got back the original configuration. Now, we are continuing with the second rotation. Second rotation, right? Yes, again the original configuration is obtained, students. Though A, position of the vertex A has been shifted from here to here, but the configuration is the same. It is perfectly matched. The main configuration, original configuration is obtained. Again, we have started the rotation. Already 2 rotations are completed. And we have got back the original configuration twice. Now we are going for the third rotation. Let's check. Yes, again we have got the original configuration after third rotation. Now again we are rotating it. And hence, not only we have got back the original configuration again, but also A has got back its original position too, right? So how many rotations took place in order to get the original configuration? Yes, 4 rotations. So here we can make the conclusion that square is rotationally symmetric, first of all. Secondly, we can conclude that its center, means center of rotation, is point of intersection of its diagonals and how many times did we rotate in order to get back the original configuration? Yes, 4 times. So order is 4, means order of rotational symmetricity is 4, and angle of rotation, by the same way we will find it out. Angle of rotation is 360 degree by 4, that is 90 degree. So here we get that square is a rotationally symmetric configuration. Now let's judge the rotational symmetricity of a rectangle. Here, one of the 4 vertices is marked by the similar way, and in a transparent paper, the same configuration is taken. You can see this. It is fully matched, right? Now, I am taking the point of intersection of its 2 diagonals as a center of rotation. And let's see that whether rotational symmetricity is there in this figure or not. So, I am starting the rotation. This is a rectangle and I am starting the rotation. It is getting rotated, and make sure we have to rotate it at an angle of less than 360 degree in measurement till it is not 360. And after covering half path, we get that the same configuration is obtained, right? So here we have just rotated here to here and we have got back the original configuration. That's why the position of A has been shifted diagonally. From this position it has come down to this position. Again I am starting my rotation. So how many times did I rotate till now? For only once. Now again I am starting my rotation. And then after covering the remaining half path of rotation, I am getting the original configuration back. And not only that, the position of the vertex A is again obtained. That is, it has come to this particular corner point. And obviously the same configuration is obtained. So what is our conclusion, students? Yes, rectangular figures, after this rotation, again the original configuration is back. So rectangular figures are rotationally symmetric. Rectangular figures are rotationally symmetric because after rotating at an angle of less than 360 degree, the original configuration was obtained. That is, when we rotated it up to this position, we got the vertex over here, the vertex A over here, and we got back the original configuration. And then again further rotation, we have got back the original structure, and where the vertex also was shifted to its original position, right? So as after rotation at an angle less than 360 degree, you have got back the original configuration. So our conclusion will be rectangle is a rotationally symmetric object, right? Now, what is the center of rotation? We can see point of intersection of two diagonals, right? Now, how many times did we get back the original configuration? That is, what was the order? Yes, you are right. For 2 times, right? So order of rotation is 2. So what about the angle of rotation? Just 360 degree by 2. That is 180 degree. And hence, our conclusion is rectangular figures are rotationally symmetric. Now let's judge the rotational symmetricity of a parallelogram, and that's why again I have taken the same configuration on a transparent paper, and the same vertex is marked over here also. And obviously, as I have already told you, I have selected intentionally one of the 4 vertices. I have marked intentionally one of the 4 vertices for your convenience so that you can understand the concept exactly. Okay. Now it is placed. You can see it is fully matched. Here it is the position of this vertex. Now I have to check that whether this configuration is rotationally symmetric or not. Let's start the rotation. Make sure the rotation, the angle of rotation must be less than 360 degree. And at that particular angle of rotation, we must get the original configuration back. Only in that case, we can conclude that the figure is rotationally symmetric. So, we are rotating this. We are rotating this. Taking this intersection point of the diagonals as the center. Let's check what happens. Yes, we have got back the same configuration, but you can see, students, the position of A has been diagonally shifted. Okay, that means after covering this particular angle, we have got back the original configuration, and obviously you can see this particular angle is less than 360 degree because this has not been rotated along 360. That means it is less than 360, this particular angle of rotation. Now again we have started our rotation. And then we are getting back after rotating at this angle, at this particular angle, we are getting back the original configuration. And also the vertex A has got back its own position, right? So what is the conclusion? Is the figure parallelogram rotationally symmetric? Think over it. Yes, it is rotationally symmetric. And what about the center of rotation? What was the center of rotation over here? Just intersection point of the diagonals. So here also we get center is point of intersection of two diagonals. Right? What about the order? How many times did we get back the original configuration? Twice. So this is 2. And what about the angle of rotation? Yes, 360 degree by order means 2. That is 180 degree. And hence the conclusion is the figure is rotationally symmetric. Let's check the rotational symmetricity of a rhombus. Here this is the configuration of a rhombus, and one of the 4 vertices is marked as capital A, and here the inclination is along the clockwise direction. You can see this. And the same thing has taken place, that is on a transparent paper, the same configuration is taken. Now let's judge, and here the intersection point of the 2 diagonals is initially made as the center of rotation. Now I am starting my rotation. Okay, it is getting rotated. It is again rotated. Okay. Yes, now the same configuration is obtained, though A has been shifted diagonally. Right? Same configuration is obtained. Now again I am starting my rotation. That is once only I have got back the original position. So let's see what happens after further rotation. Is getting rotated. And again the configuration is obtained. You can see this, right, students? So here we get that A has got back its original position. The same configuration is further obtained, and here the configuration has been repeated through a rotation less than 360 degree. Because here for the first rotation we have got the vertex A has been shifted diagonally and the configuration was obtained, and again from this position it was rotated through an angle less than 360 degree, and again the same configuration was obtained. So what is the conclusion? Yes, it is rotationally symmetric, and its center of rotation what was that? That is intersection point of the diagonal. Again, intersection of diagonals. What was the order of rotation? How many times did we get back the original configuration? That was 2. And angle of rotation was again 360 by 2, that is 180 degree. And hence we get that rhombus, the figure rhombus, is rotationally symmetric. Now we shall judge the rotational symmetricity of a regular hexagon. Here you can see a configuration of a regular hexagon is taken, and with one of the 6 vertices as capital A. Here I have marked it, and the same configuration is taken on this transparent paper also. Now here you can see it is fully matched, right? Now taking the intersection point of its diagonal as center, I am starting the rotation. So let's see that whether through a rotation of less than 360 degree we can get back the original configuration or not. Yes, we have got back the original configuration again, right? And the position of A has been shifted from here to here, that is along the side. Again the rotation is taking place with the same center, and again for the second time we have got back the original configuration, and A has been shifted from here to here. Now again rotation is started with the same center, and again the configuration is obtained, right? It has been shifted. A has been shifted from here to here. You can see this. Again with the same center the rotation is taking place, and then for the 4th time we are getting the original configuration back. With the same center again we are rotating, and again the original configuration is back for the 5th time, and then through further rotation of an angle less than 360 degree we are getting the original configuration back. Not only that, A has got back its original position also. So what is the conclusion? Yes, regular hexagon is a rotationally symmetric figure, and its center of rotation is, what was the center? Point of intersection of its diagonals. Point of intersection of diagonals. And what about the order of rotation? How many times did we get back the original configuration? 1, 2, 3, 4, 5 and then 6. That is 6 times. So what about the angle of rotation? That is 360 by 6 by the formula. That is 60 degree. So here we get that a regular hexagon is a rotationally symmetric figure, and this way you can find, you yourself can judge it, that all the regular polygonal figures are rotationally symmetric, and hence the order of rotation of all these regular polygonal figures becomes equal with the number of sides of it. So here we get that regular hexagonal figures are all rotationally symmetric figures. Now we are judging the rotational symmetricity of a very interesting figure. Here you can see this is a circle, right? This is the center of it. And if you place this circle which is drawn on this transparent paper on it, you can see it is fully matched. Make sure, students, you rotate it at any angle, whatever you wish. Always, that is less than 360 degree, at any angle less than 360 degree, always you are going to get the original configuration, right? Always you are going to get the original configuration. So this circle is a very interesting figure. Obviously it is rotationally symmetric, and here you can see that this center, that is center of the circle, which is the point of intersection of its diameters, is treated as the center of rotation, and hence whatever be the angle of rotation, we are always going to get the original configuration. And obviously this angle of rotation is less than 360 degree in all the cases. And hence it is obtained that center of the circle is the center of rotation of it, center of rotation. And what about the angle of rotation? Any angle of rotation, any angle, any less than 360 degree angles rotation will give you the same configuration, right, in all the cases. So what about the order of rotation? As at any angle you are going to get the original configuration back, so order of rotation will be infinite. Okay, that is any order of rotation, any number, innumerable number of order of rotations are going to be obtained for the circle. So hope this video will be helpful for you for developing the concept of the rotational symmetry. Thank you. Take care. Bye, students.